Phoenix is a powerful web framework built with the Elixir programming language. It is designed to create scalable and fault-tolerant web applications that can handle high traffic. Phoenix uses the model view controller architecture and leverages Elixir's concurrency features to offer real-time performance. This makes it ideal for modern web applications requiring dynamic and interactive user experiences. The architecture of Phoenix is modular and layered, separating concerns for clarity and scalability. The web interface layer handles HTTP requests and WebSocket connections, interacting with users. The business logic layer contains contexts, controllers, and live views that manage application data and behavior. The persistence layer uses the Ecto library to communicate with databases, ensuring data is stored and retrieved efficiently. Phoenix LiveView allows developers to build real-time, interactive web applications without writing JavaScript. It keeps the state and logic on the server and sends HTML updates to the client over WebSocket connections. A LiveView module typically includes a render function to display HTML, a mount function to initialize state, and event handlers to process user interactions, enabling dynamic user interfaces. LiveView follows a clear lifecycle starting with mount, where the initial state is set up. Then the render function generates the HTML view to send to the client. A WebSocket connection is established to keep the client and server synchronized. User interactions trigger handle event functions, and any changes update the view in real time by sending HTML diffs to the client, providing a smooth user experience. State management in LiveView takes place entirely on the server using socket assigns. This approach ensures consistent and reliable state across clients. LiveView supports both stateless and stateful components, allowing state to be encapsulated and managed efficiently. Communication between components or with their parents happens through messaging or update commands, simplifying coordination between UI elements. Phoenix LiveView uses a PubSub system to broadcast messages to multiple clients in real time. By subscribing LiveView processes to specific topics, updates sent anywhere in the system can be pushed to all connected clients instantly. These incoming PubSub messages are handled via handleinfo functions, which update the LiveView's state and trigger HTML re-rendering, enabling multi-user synchronized experiences like chats or notifications. To optimize the performance of LiveView applications, several strategies are recommended. Using temporary assigns allows ephemeral data to be cleared after rendering, saving memory. Breaking large live views into smaller components isolates state and limits re-renders. Leveraging streams efficiently renders dynamic lists. Throttling high-frequency events prevents overloading the server. Heavy tasks should be offloaded to background jobs, and database queries should be optimized to fetch only required data. Security in LiveView applications is critical. Always authenticate users before mounting live views and authorize every action server-side. Protect sensitive routes using proper plugs and verify session tokens on socket connections. Logout events should broadcast disconnect messages to close connections securely. Input validation and rate limiting help prevent abuse or denial of service attacks, ensuring the application remains safe under all conditions. Deploying LiveView applications involves best practices for reliability and scaling. Building releases with tools like Mix or Distillery prepares the app for production. Clustering nodes synchronizes state and PubSub messages across servers. Load balancers should use sticky sessions to maintain WebSocket connections. PubSub adapters, such as RIDIs, enable distributed messaging. Zero downtime deployments can be achieved with hot upgrades, while containerization and automated CI/CD pipelines help streamline deployment and scaling. The future of Phoenix LiveView includes improved JavaScript integration for seamless interaction, enhanced support for nested live views and components with better lifecycle hooks, and more client-side customization options. Performance will continue to be optimized by reducing latency and payload sizes. Advanced debugging tools and support for mobile and edge deployments will expand, driven by the community to improve developer productivity and user experience. To learn Phoenix LiveView, start with the official documentation and courses like those from Pragmatic Studio. Books and online tutorials provide step-by-step guidance. Participating in community forums, Discord servers, and GitHub projects offers support and real-world insights. Engaging with podcasts and coding videos enhances understanding. Practicing by building small projects will reinforce concepts and build confidence for larger, production-ready apps. Phoenix LiveView powers many real-world applications, such as collaborative tools like Scrum Poker and chat apps that update instantly. Live dashboards monitor metrics in real time, while auction and crowdfunding platforms handle multi-user interactions live. Collaborative editing apps synchronize changes across users. Financial apps use LiveView for dynamic stock tickers and notifications. Polling and survey apps can provide instant result updates as users interact, demonstrating LiveView's versatility.
If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.